Good morning, everyone. My name is Shivan Reddy, and um, along with Neha Reddy and Ritik, we have done our project on optimization of organic acid for intimate care applications by RSM. Coming to the aim, our aim is to optimize the organic acid for intimate care applications by RSM. And our novelty is to the best of our knowledge, no one has optimized the antibacterial, antifungal, and biocompatibility properties of organic acids, which are succinic acid, malic acid, citric acid, and ascorbic acid. And optimization for intimate care applications is being done by us using different compositions of this organic acid. And also, we want to find out the synergetic effect of different compositions of organic acid for antibacterial, antioxidant, and hemocompatibility. And coming to the introduction, lotions and creams have many toxic chemicals. These chemicals have many effects on the body and which are used on day-to-day basis, which furthers the damage. Organic acids taken into account are malic acid, succinic acid, ascorbic acid, and citric acid. Using these organic acids has many benefits, like it fights bacteria and inflammation, it improves skin's barrier function, and many more in the natural way. There is a safe range, which is minimum and maximum range of the organic acid. Citric acid has 2 to 5% range. Succinic acid has 2 to 5% range. And ascorbic acid has 1 to 20% range. Malic acid has 2 to 5% range. RSM. RSM is the response surface methodology. It's like a tool that helps us to figure out the best way to mix things to get the best result. It is often preferred because it's faster and requires fewer resources compared to simpler methods. And it is also a useful approach for improving how we prepare samples.
So coming to the first test, that is antimicrobial test. So in this test, we took 12 nutrient agar plates were prepared and five wells were punctured with a gel puncture. Then the 6 agar plates were spread with E. coli and 6 others spread with S. aureus. All the 30 samples were added to the labeled holes containing both the bacteria. Then these agar plates were incubated overnight at 37 degrees Celsius. Then the results were observed. So these are the uh, samples that we spread with E. coli and S. aureus, and we added the samples accordingly to the each of the whole labeled above. So coming to the antioxidant assay, this is the second response, R2 response. In this, we took 80 mg of DPPH that is added to 200 ml of methanol. Then after, ascorbic acid solution is made by adding 10 mg of ascorbic acid into 10 ml of distilled water. Then 4 ml of DPPH and methanol solution is taken as negative control. Then 4 ml of DPPH and methanol solution that is added to 200 microliters of ascorbic acid solution that is taken as positive control. For samples, 200 microliters amount of sample is added to 4 ml of DPPH and methanol solution. Then the test tubes were then kept in dark conditions for an hour before checking an OD. OD is measured at 517 nanometers with methanol as blank. With the help of the resulting OD values, antioxidant activity was calculated using this formula. For calculating antioxidant activity, we use this formula. So these are the different samples mentioned in the figure 7. So this is the wavelength mentioning 517 nanometers in figure 9 that we use for checking OD. So coming to the R3 response, that is hemocompatibility, in which we mixed 5 ml of saline to 4 ml of goat blood in falcon tube. Then after we added 0.5 ml of this solution to 32 Eppendorf tubes. Then we added 100 microliters of 30 samples into the labeled Eppendorf tube. Then the additional 2 Eppendorf tubes are labeled as positive and negative control. In the negative control, we added 100 microliters of 0.1 normality HCl to the saline goat blood mixture. And for the positive control, we added 100 microliters of saline to the saline goat blood mixture. These Eppendorf tubes were then centrifuged at 3000 RPM for 10 minutes. Then the supernatant is then collected and the OD values are checked at 545 nanometers using a spectrophotometer. Then the blank for checking the OD, we used saline for checking blank as OD, and this is the formula for checking hemolysis percentage.
Now coming to the results, antimicrobial test results. So starting with these figures, we can see the zone of inhibitions for all the samples that we have added with respect to E. coli and esophagus. Now we haven't gotten two samples results, the 20th sample that we used with E. coli and the 22nd sample that we used with esophagus. This is the figure that consists of the zone of inhibitions with the agar plates that were spread with esophagus. Here in this table, we actually calculated the dimensions of zone of inhibitions horizontally, vertically, and diagonally in millimeters. And then we calculated the mean plus or minus standard deviation values. Here the highlighted values show very good values and which can be used in any kind of intimate care applications. Now coming to antioxidant assay. So as soon as we add DPPH and methanol solution to the samples which show positive results have changed their color from purple to yellow, whereas the ones which did not change their color show negative results. Here we can see from the figures itself that the samples that have shown yellow as well as purple. Now we check the OD of all these samples at 517 nanometers, and then we calculated the antioxidant activity in percentage, which was shown by the formula given below. We again did the experiment for antimicrobial test results for getting the before samples result. These were the two samples for the results that we could not get before. And we again calculated the dimensions of these zone of inhibitions. And again, the highlighted values are the ones which show good antimicrobial properties. Now coming to hemocompatibility assay, we optimized few of the solutions from the above tests that are 18, 15, 27, and 30. And then we did the hemocompatibility test for only 4 of these samples, along with positive and negative control. We then checked the OD at 545 nanometers, and then we calculated hemolysis as well as hemocompatibility as per the formula which was shown before in the earlier slides. Now for positive control, we got 0.134, and for negative control, we got 0.1.
So this is the RSM software. In the RSM software, we use StatEase 360 application for checking the antimicrobial test for E. coli. In this, there were various fit summaries such as linear, cuboid, cubic, quadratic, and quartic. In which we took cubic model. So these are the different combinations of acids. This is in which A is labeled as citric acid, B is labeled as malic acid, C is labeled as succinic acid, and D is labeled as ascorbic acid. These are the various combinations of model that showed p-value less than 0.01. AB is the combination of citric and malic acid. CD is the combination of succinic and ascorbic acid. Like that, these were the combinations of different acids from the StatEase software. So this is the graph predicting the actual values and showing the actual and predicted values that the data we loaded in the software. So it signifies that the points present on the straight line, they showed the good composition. They are the solutions were all on the straight line on the graph. So here it comes, A is the citric acid, B is the malic acid. This is for the E. coli. So in this, the red dot signifies the optimized concentration of solution. This optimized concentration of solution that we can use in the use for our research. Thank you.